Welcome to this Landwise presentation on irrigation uniformity for irrigation operators and crop managers. When doing an irrigation system performance evaluation, three of the key things we're looking for are distribution uniformity, applied depth, and application intensity. We're going to focus for a bit on distribution uniformity. In an irrigation context, we tend to talk about the low quarter uniformity. For a system that has a DU of 0.7 versus a system of 0.9, that lower performing system will use half as much water again to achieve the same application depth as a better performing system. To calculate DU, we need to go and put some buckets underneath our irrigator and collect some water. So for this example that we're going to be working through, we've gone into the paddock with 16 buckets, we've placed them under a travelling irrigator, we've brought them back and we've put them into an Excel spreadsheet and we've produced this graph. Once we've entered our data, we're going to sort it in order from lowest volume through to highest. And of course we're talking about DU-LQ being the lower quarter. So we're going to look at our lowest 4 buckets and find the average volume in those 4 buckets. We're then going to divide that by the average of all of the buckets to work out our DU. So in this scenario, our lower quarter mean is 540 mils and our overall mean is 600 mils. So 540 divided by 600 gives us a DU of 0.9. In terms of irrigation scheduling, if we wanted to apply 30 millimeters to our crop, we can use that DU number to work out how much water we need to apply to ensure that 7/8 of that crop receives the minimum of 30 millimeters. So 30 millimeters divided by 0.9 equals 33.3 millimeters. That means that we have a wastage of only 3.3 millimeters. We're going to do a second example here with a system that's given us a lower DU. So we have our 16 bucket measurements, we've ordered them lowest to highest, and we work out the lower quarter mean and the overall mean or average. So 300 is our low quarter mean, so 300 divided by 600 equals 0.5. So we have a DU of 0.5 for this system. We can already see that there is a significant variation in the application that we're getting on to these paddocks. So what does that mean if we try to apply 30 millimeters to 7/8 of our paddock? So same equation as before, 30 millimeters divided by 0.5 DU equals 60 millimeters. That's 30 millimeters of wastage. Twice as much water is being used to make sure that 7/8 of the crop is receiving 30 millimeters. What that means in reality is that bucket numbers 1 and 2 are still not achieving 30 millimeters, yet our other buckets, say 15 and 16, they're having twice as much water put on. Application depth is a key measurement that's calculated when we're doing a performance evaluation. It's really important to test this to confirm that we're applying what we believe we are. So for example, pivot panels or linear panels will say you're applying 15 millimeters per pass, but that relies on the speed calibration being set correctly at the time of commissioning. So it's really important to test the speed and understand if the panel is correct. Travelling guns and booms don't have displays that tell us how much is being applied, so we're making an estimate based on the manufacturer's instructions or the designer's instructions. It's really critical when we're looking at the applied depth and those calculations to consider alongside it the distribution uniformity. So there's a graph here that shows the importance of this. So in our test we were trying to apply 14.5 millimeters and we have a calculated average, which is the yellow line, of 14 millimeters, so 0.5 millimeters different. You'd think that's great. However, this system has a DU of 0.5. So we can see that although the average target depth is exactly what we want, we've got these really high bits of water and these really low underwatered parts of our paddock. This is why we really need to get that distribution uniformity sorted to make sure that our application depth is even across the field. The third calculation that we can undertake when we're doing a performance assessment is the application intensity, expressed as like millimeters per hour, like rainfall events. Different soils will have a different intensity that they can handle or a different infiltration rate. So when we're doing our test, it's really critical that we look for areas of ponding and runoff, measure those and understand those, and work out if the system itself is actually applying water too fast for the soil to handle. Excess application is not ideal. It leads to soil erosion and it also will lead to leaching. So this means that we will have our nutrients being washed away, taken into groundwater, but also means that the cost of that nitrogen or other nutrient is not being utilised by the plant. Therefore, it is a cost to production.